there, everybody. In types of reactions, part 2, we're going to finish up the types of reactions. So hopefully, let's everybody say wish well our people that aren't here. We're missing Gabby, Brianna, and Stephanie. So everybody say hi, guys.
Hello.
Okay.
I miss you. I miss you,
Okay.
Steph.
All right. So come on back, quick. So we already took these down, so don't take them down again. We started this last class. This is the second part of it. I just wanted to break it down into 2 different things. But we should be able to recognize the type of reaction based on an equation, and we should be able to predict the products of reaction based on the reactants. So last class we talked about composition and decomposition reactions. We already took this down, so don't take this down again. But we're going to talk about the rest of the format of the types of reactions. First one is single replacement. And looks like my annotation. We haven't done this. This is new. So this is something you guys are going to want to take down. So in a single replacement reaction, what happens is, let's take a look at our ions. So we have copper, which is a +2, and nitrate, which is a -1 ion, and magnesium. So what ion does magnesium form? This is the element magnesium, but what ion does it form? What's the ion magnesium, Laura? What's the ion magnesium?
I'm so confused.
What is it? What charge?
What? Positive.
Positive what? Mg
Mg positive.
plus 2.
Yeah.
So which one is Mg going to take away? Is Mg going to be attracted to the negative or the positive?
So negative.
The negative. Why? Yes. Because what? What
You
attracts?
need to cancel them out, you know?
Yep. Opposites attract. So that's why we end up with magnesium nitrate. Magnesium takes away this nitrate and brings it over here. So we're left with magnesium nitrate. And what's left over? If magnesium takes nitrate away, what's alone? Copper. That's why we have this. And yes, Connor?
Why?
No, just write whatever you want down here. So, look. So the nitrate just goes with the magnesium. And then you're left with the nitrate and the magnesium together. Oops. Similar thing here. If you guys are looking at aluminum, Al is +3, chloride is a -1. Fluoride is an F-. So which one's the F going to go with?
Positive.
The positive to make aluminum fluoride, and you're left over with chlorine. We'll talk about these guys in a second. These are diatomic. Actually, technically they're called homonuclear diatomic elements, but that's a lot of words. So because they have the same, they're made of 2 atoms with the same nucleus. Here you have Cl2, here you have F2. We'll talk about a way to remember those in just a second. Okay? Ready to move on, guys? Diatomic elements. Don't worry about that. We're going to cover that in another slide. So, single replacement. Hold on. So, here's modeling a single replacement reaction. Here we have copper 2 chloride, which is CuCl2. Copper's the positive, chloride's the negative, reacting with oxygen. This is oxygen O2, like gaseous oxygen. And so what's the charge of what's that? This is Cu and that's Cl. Cl minus. So what charge? This is oxygen right here. O2. It's another diatomic element. But what charge does oxide have? What's the charge of oxide, Laura?
Let me see. 2 negative.
-2. Good. So which one is oxygen going to go with? Is oxygen going to go with the copper or the chlorine? It's going to go with the copper. That's why you're left with copper 2 oxide and chlorine. Okay? You guys see that? How we have the copper going with the oxygen. We're left with the copper with the oxygen. And we're left over with the chlorine. I think I forgot to put a chlorine in there, but
Okay.
that's all right. No, we can add it in real quick. I know. All right. So these are the diatomic elements I was talking about. They're elements that are always in pairs with their elemental state when they're not bonded to anything else. So there's a list of them down here, and these are the ones we're going to have to know or write. So guys, what this means, look up here. So if you're ever talking about the element fluorine, you're referring to F2 or Cl2. So like fluorine is F2. Chlorine, the element, is Cl2. Bromine, the element, is Br2. Iodine, the element, is I2. Hydrogen is H2. Oxygen, O2. And nitrogen, N2. Whenever you're referring to the element oxygen, like our atmosphere right now, we're surrounded by 99% nitrogen and oxygen. Those are diatomic elements. So we just don't have atoms of oxygen. They're actually bonded to other oxygen atoms. So you have a pair. So that's you guys may have seen that in biology when you talked about photosynthesis and cellular respiration. You notice oxygen is always O2. Okay. That's a good point Connor just brought up. So this is only when they're in elemental form, when they're elements, not when they're compounds. So you can have something like CuO. That's fine. That's copper 2 oxide. Doesn't have to be CuO2. This because this is a compound. Okay? So that's a key thing to understand. Okay? So let's move on. So how you can remember the diatomic elements is they're the honorable 7. Okay? Honorable, H, O, and N. And they kind of make a 7 on the periodic table. Do you guys see that? A little 7 right here. Honorable 7. H-O-N, and there's 1, 2, 3, 4, 5, 6, 7 of them. So that's a way you can remember the honorable 7. They're all the diatomic elements. Okay? So that's just something you can do. So everybody, take a look up here. Next one's double replacement. So copy this one down. So double replacement is when you have 2 ionic compounds that switch anions or cations. It doesn't matter what you're talking about. But really, you have to look at your charges again. You have this is Na, which is sodium, which is a +1 charge. Chloride, which is Cl, which is a -1. Lead, which is a +2, and nitrate, which is a -1. So I'll do it with the charges. So what's going to go with what? Is Na going to go with lead or nitrate? Sodium going to go with lead, which is positive, or is it going to go nitrate, which is negative? What do you think? What attracts each other? Do positives attract positives? Positives attract negatives. So that's why we end up with NaNO3 and PbCl2. Because the Pb, basically what we're doing is we're switching the positive ions. Okay? So, just look up here for a sec, guys. I just have a... So what happens is we have lead and sodium going with nitrate, and lead going with chloride. Oops, didn't come out right.
My mother said she's willing to make a Christmas party.
Oh.
So, take a look at this, guys. So, we're basically effectively switching our cation. So, I just fixed this, so it makes it look more correct. So, our lead starts with nitrate, ends up with chloride. Our sodium starts off with chloride, ends with nitrate. Right? So, if you guys take a look at our other example right here, a similar thing happens. Where we have calcium, which is +2, chloride, which is -1, aluminum, which is +3, phosphate, which is -3. So our calcium goes with our phosphate. Our aluminum goes with our chloride. Does that make sense? So AlCl3, aluminum chloride, and calcium phosphate. So moving forward. No, kind of, but okay, I don't know. Just all you have to do is remember that opposite charges attract. So take a look at this molecular model up here. Sam, can you keep your hand, please?
Yeah.
So we have our potassium and our chloride, and we have our lead with our nitrate. And the lead goes with the chloride, and the potassium goes with the nitrate. So you're switching partners. So you're left off with potassium nitrate and lead chloride. So pretty simple example. Last one we're going to talk about today is combustion. And you guys actually talked about this last. So a combustion reaction is when a hydrocarbon or carbohydrate. Hydrocarbon is an element made of hydrogen and carbon. So it's going to be some number of carbons and hydrogens, or a carbohydrate. Carbohydrate, you see the word carbo, which is carbon, hydrate, which is water. So it's carbon, hydrogen, and oxygen. Reacting with oxygen, and we always form the same products. Carbon dioxide and water. Those are my two products all the time. So you guys see, I make carbon dioxide and water. So it's always going to be those same products. So this is an easy one to recognize. Okay? So modeling combustion, you just, and effectively, guys, look up here. Look at the board. All right? Eyes up here. So we have carbon with hydrogen to start, and the oxygen goes with both carbon and hydrogen, forming carbon dioxide and water. So that's it. So order matters when you're predicting this, and this is something you guys are going to want to write down. Okay, so these are the steps when you're predicting our products. Let's go over a couple. I want you guys to try these 3 examples first, and we'll talk about, I want you guys to predict the product. So first thing you guys want to do, identify the type of reaction, then predict the products with the correct formulas, and then balance the equation in the end. So we'll write these down and do these. So calcium oxide reacts with chlorine. So we have CaO and Cl2. Remember, chlorine's a diatomic element. So what are we going to make? We have to look at our charges. So what's the charge of calcium? Ca +2. Oxide is O -2. And chloride, the ion, is Cl -1. So what's going to end up with what? Which one is chlorine?
Calcium.
Chlorine. How do you know that?
Because it's positive.
Opposite charges, yeah. So we end up with calcium chloride plus oxygen. So I'm going to make calcium chloride is CaCl2. Oxygen is O2. So I'm going to want to balance this equation. You guys can balance it later. So, I just want to get through the model before. So this one, we have C3H8, which is propane, which is in your gas tanks, plus oxygen, which is O2. Now, what type of reaction is this? Which one of these? This is combustion. So what are the products of combustion we just talked about? Water. And what was the other one? There's two products of combustion. Oxides of carbon and oxides of hydrogen. We have our oxide of hydrogen right here. What's our oxide of carbon? It's a common carbon oxide. Carbon dioxide. So we have H2O plus CO2. So then I can balance them later. Last one. Sodium hydroxide, NaOH, plus magnesium nitrate, MgNO3, 2. Now, let's look at my charges. Na is plus, OH minus, Mg 2 plus, and NO3 minus 1. So what's going to end up with what? Take a look up here, guys. Which one is sodium going to end up with? Is it going to end up with magnesium or nitrate? It's going to end up with nitrate. How do you know? What's true about? Yeah, positives go with negative. Opposites attract. So we have sodium nitrate. And what's the other product going to be called? Magnesium hydroxide. Good work. So we left with NaNO3 plus MgOH2.
Wait, so it's sodium, magnesium?
No, sodium, no, those are two positives. They switch. So your sodium is going to switch with your magnesium. And we end up with sodium nitrate plus magnesium hydroxide. All right? Yeah, I'll leave it up. So we're pretty much done, so.
What days do you